Hello, everyone, and welcome back to part 2 of the Creating Google Translate from Scratch series. I'm happy to see you're back. If you didn't catch episode 1, definitely check it out. Quick overview though. What we did was we just loaded up. Well, first we went over a little bit of how this model works behind the scenes. And then we went ahead and put together a little example here using this pre-trained model and tokenizer. That being said, they haven't been fine-tuned yet. So today what we're going to be doing is primarily focusing on pulling in the data and getting it ready to go through this model, all this language data that we'll be using. So if that sounds interesting to you, definitely stick around. And also, subscribe to the channel. It helps out, and also will help you keep in tune with these episodes as they come out. Awesome. So let's get right into it. The first thing I want to do is give an example of exactly how this tokenizer is going to work. Remember, the tokenizer will help us break down a sentence into its parts or its pieces. Sometimes those will be full words. Sometimes it will be parts smaller than a word. That's what the sentence piece library does. And sorry, just one thing before we get into it, I forgot to mention, do check the about section, by the way, if you want a link to this code. It will be linked down there, and relevant other things too, articles and such. So let's start with an example. Input string. So this will be what we're translating. So let's define a structure for what we want. We need to define the language we want to translate into, right? And that actually has to go into our input, right? So we can put that directly into our input string, and that's one really easy way to do it. So one way lots of models do this is they have a tag. It's not the only way to do it, but let's say we want to translate this to Japanese. Maybe we put a JP tag. I'm just making this up. You can really use anything you want here. But we put this JP tag, and then we put something like, this is a test. I'm also going to put something like, these are just random letters. So you can see what the tokenizer does when we have random letters like this, not a real word. Because we do have a limited vocabulary, right? And if a word's out of the vocabulary, well, we still have to handle it somehow. So let's take the input IDs, or not take them, we're going to make them by doing tokenizer.encode example input. Go ahead and do this input string, and return tensors equals PyTorch. This is just what we did before, right? We can go ahead and print these input IDs. And I know we did this last time, but hold on, I'm going to do something else here too. So let's print out these input IDs, what we expect, right? We get the tokens. What do each of these tokens mean though? Because we saw last time there isn't a one-to-one mapping, right? JP, this is a test in Bouygues. We have all these extra tokens. What are they representing? We can actually visualize this by getting those tokens back into their, not ID, but the actual tokens. So we can tokenizer.convert IDs to tokens and pass in our input IDs. And then we go ahead and print that out. Tokens. And what do we get? We get the actual tokens that it's seeing. So you can see there's an underscore side error, or this thing right here, the caret. And one thing you might be curious about is you see lots of these underscores. Where are these coming from? And underscores are generally a way that encoders tend to represent spaces or starts of words. I don't know exactly how this tokenizer does it because they all work a little bit differently, but you can see at the starts of lots of these words, not all of them, but most of them, or yeah, I think all of them, they have one of these underscores. You will see, for example, this specific token right here, the JP thing, and also the NBUIG. These aren't actually in the vocabulary, so what ends up happening is they get split up into their components, which is very interesting. That means, we still have a way to feed them into our model. They just become multiple tokens. We can add vocabulary. Generally, you won't want to, but we might want to in this case for like the JP tag, or if we have an EN tag, it might make sense to add those, right? So we can have single tokens for them. We can actually look at the specific vocabulary that is here. If we do tokenizer.vocab, we should be able to see, oh yes, you can see on the left here, they have the words that are in this, and then I believe this is ranked in order of frequency or something like that. Maybe not, but The lower the number, I think the higher the frequency. So you can, as you know, this is a multilingual model. You can clearly tell from its vocabulary, it has a lot in here. I don't know what the majority of these things say. But one thing we can do is go ahead and sort by this frequency, and that might show us, you know, something interesting. So we can go ahead and say sorted, and then do a key equals lambda x x1. So this will just sort by items. Come on, come on. There we go. There we go. Take this up here. So we see if we go to the very beginning, the pad token is the very first one. -s, I believe, is end of sentence. Unknown is something unknown, though I don't think we'll end up using that unless we get some weird characters. These are all unused. This is very common if you want to add your own. Sometimes they give you these extra spaces. I think that's what these are. Once we get past these, though, we see some very common things, right? As I was expecting, we have the underscore, a period, a comma, a, s, dash, e. Yeah, these are unsurprisingly the most common things. Oh, com for .com, who would have guessed? So you can see they kind of get less common as we go down. Oh, cool. That's the vocab. What do we want to do next? Well, let's actually, I'm going to delete this output and comment this out because it's kind of annoying to scroll through all that. But what we want to do next is get a data set, and I have a data set prepared for us, or I didn't make it, but it's provided by Hugging Face. Oops, didn't mean to do that. Here is the actual website, and you can see it's the alt data set provided by Hugging Face, and it has 13 languages. We'll just be pulling 3 to give an example of going from one language to another and showing that we can do that with more than just 2. But you know, you can expand this later if you're interested in working more on this. You'll see sort of the details as we actually code this up. So this is how we load the data set right here. We just go load data set in the name. The name is alt. So once we go ahead and do this, we should, that will take a second, but we can split out a train data set and a test data set. So if we go, oh, it should be test. If we go ahead and do this, we can print out train data set. We see, what do we see? We have 18,000 examples, and in the test we have 1,000 examples. Normally this wouldn't be nearly enough to train a machine translation model, especially something like Google Translate where we're going between all these languages. But because we already have a pre-trained model and we're just doing the fine tuning, this will actually be plenty to give us a fairly good model. As you'll see, you know, don't take my word for it. We'll be coding it. So let's go to the train data set and see what the actual data looks like. If we take the first instance, we can see we have some IDs, but then in this translation, right here we have BG, EN tok, or tok, FIL, FIL, HI, ID, JA. We have all these languages in the translation. So what we can do is we can choose what languages we want, and we can just pull out those pairs. So if we want to do an English to Japanese training, we can pull out the English right here, and then the output or the target can be this Japanese text. So this format's actually pretty good. It's not too convoluted or anything. So now that we know what this looks like, let's create, because remember, we want to have this sort of idea, right, where we pass in not just the string, but also a token for the language we want to translate to. Let's make a mapping between these actual things we'll be pulling the data from and what tokens we want to add to the text. And then when we format this, we'll have a clear mapping. So this is the mapping I went ahead and created, just called lang token mapping. And we map the EN language to the this EN token. Now, remember, I'm just making these ones on the right up as I go. On the left, I'm just matching them to these. So JA goes to JP for Japanese, and ZH goes to a ZH tag for Chinese. You feel free to add more of these in here. You totally can. It should work just as well. So, or I guess as you add more, you might get slightly less accurate, but you should be still pretty accurate on the whole. So we have that. But if you go back up here, you can remember we don't really have this JP tag in the vocab. Another way we can check is we can do a data, or what is it, a tokenizer.vocab, and then we can try an index on, what is it? well, we saw JP was there, right? So we should get something. But if we have the tag, yeah, there's nothing there. So we need to go ahead and add those. I guess we could try it without adding them. It would probably still work okay, but just for safe measure, we can add them like this. So we say the special tokens dict is additional special tokens maps to, and then you just give a list of all the extra tokens you want to add. So here, ling token mapping.values is these tags right here. And then on the tokenizer, we can call add special tokens and pass in this dictionary. That's added it to our vocab once we've done that. But remember, our model already has a predefined like embeddings layer, and that has, you know, one sort of node for each of these possible vocabs, or one of these possible words in the vocab. So we need to change that too. Luckily, there's an easy function for that. We just call model.resize token embeddings and pass in the length, the new length of the tokenizer, and it will go ahead and resize accordingly. And just in case you're curious, the actual synapses will only be, they'll only be randomly initialized for these new connections we're adding. All the old ones should stay unchanged. So let's go ahead and run that, and we should be able to do that without any issues. Awesome, awesome, awesome. So we did some tokenization up here. That being said, when we're doing training, we are going to want to pass in batches of data. And when we're passing in batches of data, we want to pass in batches of input IDs. So this one has, I don't know, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 tokens. But if we have a sentence with 14 tokens, one with 10 tokens, one with 20 tokens, you can't have a torch tensor with like those different sizes, right? So what we need to do is we need to make all these equal the same size. So let's say we have 8 examples, we can have a shape or a tensor that's 8 by, and then the sequence length of all these. So say 20, this model happens, this pre-trained model happens to have a limit of 20. If you want to pre-train your model from scratch, you can change this, though it is a little bit of extra work. So 20 is what we will be going with just because it's already in this model. And if it's above 20, we can just truncate this, right? We just cut off anything after the 20 mark. But if it is less than 20, we can just add on padding tokens. Remember, there's a special token for padding, and we can just add those in. So let's go ahead and define that variable. Let's come up here just to define global variables, and we can say max sequence length is like 20. Cool. And if you're curious how I knew the max length was 20, if you do model.config, it has lots of these. Model.config.max length, it's 20. Yep, you might as well just put that here. That's a little cleaner. And cool. So we have a max sequence length. How do we actually do all this padding, all this stuff? Luckily, there's a super easy way. I'll go ahead and just copy it over because it's not too different from what we were doing before. We have the tokenizer encode just like before, passing the input string. Here's what's different. This right here, this padding equals max length. That means we will pad it up until the max possible length that we're passing in here, which is what we just defined. It's 20. And truncation true means if it's over 20, we will just cut off the other or the later part of it up, and so we have exactly 20. So if we go ahead and do this and print out token IDs, you can see we have zeros here now, whereas there was nothing here before, right? And that's because zeros are the index for the padding token. You can also see if we go ahead and just put in, you know, a bunch of gibberish here, it should truncate it. Yeah, so you see it's limited to 20. This is 5, 5, 5, 5. That's 20. So that is the function, same function we'll be using. It does all this work for us. We're pretty lucky. It's fairly simple. So all we need to do now is take this data from the data set and transform it like this. Now, this is going to be not too difficult. So let's make functions, right? We can have a function for encode input string. We can have another function for encode target string. So the input string will be the input to the model. The target will be what we're expecting, right? We'll need a target for when we're training. And both of these are fairly simple. I'm actually just going to go ahead and copy and paste them over. It's just Python, you know, sorry if you want me to go over this, I'll very briefly go over it, but you know, this isn't a Python tutorial. We want to get into the juicy part. So all this is doing encode input string. We take in the string. This is the map we defined. We put a target language. So this could be like JP or ZH. And we have our tokenizer from earlier, our max sequence length, all these things you already saw. And we just encode it as I just showed you. We pass in the text, but not just the text. We add a prefix, the target lang token. So that would be like adding JP or maybe ZH to this is the sentence. And then we end up getting the combination of both of those. So that's what's going into our input string. And the reason this isn't in our output string, you might think, oh, it's the target language. Why don't we put the token in the output? That's because everything needs to go into the input that we're feeding in, right? It will see everything in the input, and then when it's making the output, it can see the input too because of the way the attention is working. So it should be able to see the fact that we have this JP token. Return as tensors, padding, and truncation as we just saw it with the same max length. So this is exactly what we just did. This is why I don't want to really go over it. Now and then we just return the IDs, right? The encode target string here is almost the same thing. The one difference you'll notice is we don't have this target lang, right? Because for the output, it's just what we expect to get out. We shouldn't have any extra tokens in it. It should just be the raw translation. Fairly simple, fairly simple. We'll go ahead and test these in a second, but for now, assume they work. And the next function we want is going, I'm going to call it, what am I going to call it? Let's do def format translation data. Let's take in like the translations. So this would be, I guess, do we want to do like a list of translations here? Or I guess this would, so let's say we input, we go back up here, let's input this dictionary right here, for example. So we input all the translations for all the languages for one example. In that case, we can go ahead and we'll also need the tokens map, tokenizer, sequence length. We can set a default value. I know we are using 20. I'll just set 128 as a default value because why not? Most models tend to have more tokens available. Anyway, what's the first thing we want to do here? Well, for any training example, if we're training on English, Japanese, and Chinese, well, we have a few different training examples from one pure sort of data point we can use, right? We can do English to Japanese, English to Chinese. We're probably not going to do English to English. We can do Japanese to, I guess, English, and then Japanese to Chinese. We can do Chinese to, you get the point, right? So we have 6 different combos that we can do. That's quite a bit. So we could make those, but if we were going to use more languages, we probably don't want to make all those at once. That'd be a lot of examples. So we're going to be training multiple epochs anyway. So how about we just go ahead and we pull out a random pair of 2 and use that as our training example. So say langs equals a list of, again, sorry, I'm just going to copy these over. It's nothing too complicated. I'll slow down again when we get to the real like meaty parts again. But we just make a list of the possible languages and we do a random choice of 2 languages without replacement, so we don't do the same language to the same language, but that will give us 2 languages, an input language and a target language. So this might be English and Chinese or something like that. Next thing, we want to get the actual input and output text. So we can do that. We have the translations dictionary here. We just grab the input language or the target language. So if we go back up here, it's like we have this dictionary here. We just grab the English entry right here. That's all we're doing. Not too bad, not too bad. Next thing we want to do, and this is because I've gone ahead and checked for you guys, some of these texts are null. We want to, or none. We just want to go ahead and get rid of those. We don't want to deal with none data. It's kind of a pain. Next thing we need to do is use the functions we already made to encode these texts into their tokenized patterns, right? So if we look down here, all we're doing is using these functions we created before. and we pass in the input and target text, and we should get out the token IDs. And the last thing we need to do is just return those. And this should format a single example. So let's go ahead and try that out, make sure it's working properly. So format translation data, and we're going to use our train data set that we defined before, and we're going to take the first example. Remember, we pass in a translation dictionary. We also need to pass in our Lang token map and the tokenizer. Let's go ahead and do this. So if we do this, we should get something. Okay. So what is this? What is this? Remember, we set the sequence length to 128 by default, and that's why we're getting all these paddings. But you can see where we return the input token IDs and the target token IDs, and it looks like that's what we're getting. Now, it's hard to tell exactly with just this, so let's go ahead and actually make sure of that. So let's set input, or just in IDs, out IDs. Go ahead and do this too. So we have both of those. Let's go ahead and print them out. This isn't too bad. So we can just join so we convert these IDs into tokens, and then we join them together with spaces to get the outputs. So this is our input. So let's see, is this correct, right? We have an English tag, some text in Japanese, and then we have some English text as the output. This makes sense, right? Because we want, we want this should be random, but whatever the token is here, this English token is what we should be translating into. So this should be our output. Our output should be English here, makes sense. We can go ahead and also try another example. So Japanese to Chinese, and you can see that is exactly what's happening here. Or maybe you can't see if you don't know the difference between Japanese and Chinese, but I can guarantee you it's working. And you can see there's all these padding tokens at the end, which is good. This is good, right? Because by default, the sequence length was set to 128 right here. So we should expect a lot of padding at the end here, which is what we're saying. Awesome. So we're formatting our data, not too bad. And there's one last thing we need to do before we wrap up this video, and that is make sure we're formatting this data for batches, right? We're gonna wanna train this model with batch data. That just goes a lot faster, so you should always do it. Luckily, this is super simple. We just need to make a new function. function. Transform batch is what it's gonna be called. And we want to take in, let's see, I guess a batch of data. Makes sense, right? So this will be multiple examples. We want our Lang token map again and our tokenizer. And here's what we are going to do. We are going to have inputs and targets. And we're just going to go through one by one and call this function for each example. Shouldn't be too difficult. So we can just say for translation set in batch of translation. So translation set in batch, right? So batch will just be several examples. Or sorry, I should show you guys. If we do a train data set and then go from like 0 to 5, what you'll actually see, or let's do 2, that's a lot easier. There's not a different full example for each of these. What you'll see is that each of these keys or each of these elements are an array at this point. So it's not like we have multiple dictionaries. We have one dictionary, then each key has an array of multiple values. So what we'll do is we will get like 5 to 10. This will be a batch of data, right? And then we pass in this just like before, we pass in whatever is right here, this translation value, which will be multiple dictionaries. And that's what this batch input is going to be, in case you were curious. So translation set, so for each translation set, so this is like each one of those multiple translations for the same example, we want to format our data. And to do that, we can call this function we just made and just tested right here, right? So that's our formatted data. Now we will say if formatted data equals none, we will want to continue. This is, I guess, in the worst case scenario, it's all null. Right here, right? If one of these examples is null, we'll just skip it. That should be perfectly fine. But if not, we want to go ahead and add these to the inputs and outputs we're building up right here, right? So we extract the input and target IDs. we unsqueeze 0. All this is doing is, if you remember, all these are in this format, right? There's like an array and an array, and then we have our values. So we're just taking out this outside array and having the one thing, because we will concatenate it right after this. So yep, just append that to our lists up here. And the last thing we want to do is what I just mentioned. We will concatenate all these inputs and all these targets. And once we have concatenated them, we can return the batch inputs IDs and the batch target IDs. So that's pretty good. I know I said one last thing, but I guess there's one more function. I'm just going to copy and paste it over, and it's just going to be a generator for this data. If you haven't used generators in Python, they're super cool. All they are functions that return multiple things, but not at once, but every time you call the function, or I guess you call the function, you get an iterator, and every time you call next on the iterator, you'll get a new data, right? So in our case, we take in a whole data set right here, we shuffle it to randomize the order, and then for the length of the data set, and we specify a batch size. So for sort of, I guess if this batch size is 32, we'd start with the first 0 to 32 examples, then the next 32 examples, then the next 32 examples. So we grab that batch data right here, and all we do is we yield, the key right here, yield is how you know it's a generator, the transform batch, this function we used up here, we just call it on that batch of data and return it. If you haven't used generators, this might be a little confusing, so let me go ahead and give you a demo. So the first thing we want to do is use this data generator. So let's say data gen equals gets data generator, and we need to pass in a data set, so we'll use our train data set, our lang token mapping, our tokenizer, and a batch size of 8. Cool. Then we can go ahead and say data batch. Remember, data gen right here, this is actually an iterator, so we can say equals next data gen. Each time we call next, it will do one more loop and yield the next batch of data all the way up until the end. Well, if we were calling it a loop at least. And then we can go ahead and print these out. So let's just print out the shape so we don't have to look at this wall of text. So we'll print out the shape of the data batch 0, which is the input IDs, and the data batch 1, which is the output IDs. We see the shape for the input is 8 by 20, which is what we want, right? We should have a sequence length of 20, and we had a batch size of 8, and same for the output shapes. So this is exactly what we want, which is awesome. That, you know, that wasn't too hard. We can actually print these out just in case you want to see. It's probably going to be a bit overwhelming, but batch or data batch 0. Yeah, you know, we have example 1, example 2, example 3, and so on. That's really all we have for the data formatting, though. I think data formatting is usually the one part people are like, not data formatting again, but it is pretty important for getting these things working, and we do have it now. So we are going to end this episode here. However, the very next episode will be the last and probably the most exciting, where we actually get our model to work. So if you want to see that, make sure to subscribe, like the video, comment, let me see if you want to see more of these types of things. I really appreciate all the feedback I get. I really do take it to heart and, you know, try to improve my content with it. Anyway, thanks for watching, and I hope to catch you in the next one of these.